Pedigrees are charts of family histories which show the phenotypes and family relationships of the individuals using symbols to represent different family members. You should remember that squares represent males, circles represent females, filled-in symbols represent individuals which have a genetic condition, and a proband is the first affected family member that seeks medical attention. Now we're going to start using these pedigrees to determine what kind of inheritance pattern a particular trait has. Let's imagine we're geneticists studying pedigrees to determine the type of inheritance in a rare genetic cancer syndrome called Peutz-Jeghers syndrome. We'll call Peutz-Jeghers syndrome PJS for short. If this is the pedigree for a family with a history of PJS, what do you think this inheritance pattern means? First, do you think that this is a dominant condition, a recessive condition, or neither? If you said that this is a dominant condition, you're right. Notice how PJS is passed along directly from an affected parent to some of their children, and that only the affected children can pass PJS along to their own children. Dominant conditions rarely skip generations, which makes them easy to follow through a pedigree. Now there are some exceptions to this rule, but that's another topic for another day. Okay, we've determined that PJS is a dominant condition. Now, do you think that PJS is autosomal or sex-linked? You may remember that autosomal means that the causative gene is located on an autosome, and sex-linked means that the causative gene is located on the X chromosome. If you said that PJS is autosomal, you're correct. Here is why. If the causative gene was located on the X chromosome, then a father could not pass PJS to any of his sons, because sons inherit a Y chromosome from their father and an X chromosome from their mother. Also, since daughters inherit an X chromosome from their father, we would expect all daughters of an affected father to also have PJS if this was a sex-linked condition. In this case, the proband's father has passed PJS along to some of his sons and some of his daughters, so this must be an autosomal condition. On average, an autosomal dominant condition is passed from an affected parent to about half of their children. However, be careful not to read too much into the exact ratio within a family. Each child of an affected parent has a 50-50 chance of inheriting the causative allele. It's pretty much a coin flip for each child. It is entirely possible for a person with an autosomal dominant condition to have several children who do not receive the dominant allele, and are therefore all unaffected, just like it is possible to flip a coin 5 times and get heads every time. Now let's look at a pedigree from a different type of genetic disorder, and see if we can determine the type of inheritance again. This time, we're looking at an example of what a pedigree might look like for a rare genetic disorder called galactosemia, which is a metabolic disorder where the person cannot properly metabolize galactose. What type of inheritance does this disorder have? Do you think it's dominant, recessive, or neither? In this case, it appears to be recessive, but we can't be completely sure that it isn't some type of more complex inheritance. In a recessive condition, it takes 2 copies of the affected allele to cause the condition, one inherited from the mother and one inherited from the father. So most individuals that inherit an autosomal recessive disorder have unaffected parents. However, both of these unaffected parents should each have 1 copy of the recessive allele, which would make them carriers of galactosemia. A carrier is an individual that has 1 copy of a recessive allele and does not exhibit the trait. In a pedigree, carriers can be designated by placing a spot in the open circle or square. Some carriers of a disease are inferred by relationships to affected individuals, but with advances in our knowledge of human genetics, it's now sometimes possible to do genetic testing on individuals and determine if they carry the recessive allele or not. Because both of our proband's parents are carriers for galactosemia, each of her siblings has a 1 in 4 chance of also inheriting the condition, and a 1 in 2 chance of inheriting 1 copy and also being a carrier. As a result, nephews and nieces of the proband may inherit galactosemia if the proband siblings has kids with another person who also happens to be a carrier. Now, do you think that galactosemia is autosomal or sex-linked? If you said autosomal, you're correct. Sex-linked conditions generally affect males because they only have one copy of the X chromosome, and therefore only have to inherit one copy of the causative allele, while females have to inherit two copies of the causative allele. In this pedigree, we have one male and two females that have galactosemia, so this is an autosomal